Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera to panel PM Dr. Wan Hasrul Nizam and Dr. Amir. My name is NURHANANI HIDAYATI BINTI RASID and my supervisor is PM Dr. Lakokti. Okay, today I will present about my final year project, which is characterization of ABS film HBN polymer composite filament for fused deposition modeling. So this is my content that we will take you through. So first is research background. 3D printing, or also called as substance fabricating, may be quietly emerged innovation which permits the fabricating of physical part from a computational layer by layer approach. There are many variations which 3D printing technology construct this successive layer, including fused deposition modeling. Due to the commercial availability, relatively low cost and ease of use, FDM printers have become the most common 3D printing technology. ABS is oil-based plastic and a solid, sturdy material and high melting point commonly utilized by companies to fabricate items such as plastic carpet and filament for 3D printing. For 5, hexagonal boron nitride, or also called as a white graphene, is an analog to graphene, which is electrically insulating and thermally conductive. Proceed to the problem statement. For my first problem statement, the warpage issue arises since the primary layer does not adhere where and is peeled away from the printing stage in 3D printing. This is because of the adherence of the first layer to the printing platform due to the previous study from NURHANANI 2017. For the second problem statement is the challenging composite for the fabricate of 3D printing filament supported by the previous study from Zan 2017, which hexagonal boron nitride have the high thermal conductivity, also non-toxic cauterization, and from the Wiki 2019, acetone should therefore be added to achieve the object in ABS HBN composite. Then for the research objective and scope, my first objective is to study the effect of material properties of ABS HBN composite and pure ABS on the rheology properties of ABS HBN composite and pure ABS. For the second one is to study the effect of extrusion parameter and material properties on the microstructure of the extruded ABS HBN and also to the pure ABS filament. For the research scope, consists of the rheology testing and analysis, where the capillary rheometer testing provides us a plot of viscosity versus shear rate and also the pressure. Consider the several parameters such as load, pressure, and displacement by using test machine to the effect of extrusion parameter ABS HBN and also for pure ABS filament. This project will deal with the process of polymer filament extrusion where the molten polymer is pull into the shape done by use of pressure. Then carry out the microstructure observation by using two types of microstructure observation, which is first is optical microscope with 100 of magnification and also by using the electron scanning microscope SEM. Then conduct microscope analysis in order to observe the size, shape, fracture area, and quality of inner structure sample of ABS HBN composite and also for the pure ABS. Then this for my literature review, focus more on the main component, which is ABS, hexagonal boron nitride, acetone rheology testing, extrusion process, and also microstructure observation. For the research methodology, flowchart of project, material, and process, we go through for the first. This is my flowchart of my project, which is consists of two objectives that I will bring in the next. So for the material, ABS was selected for composite manufacture, especially in the creating plastic products such as 3D printing, automotive construction, and electronic are the important industry for ABS. This is for referred by the previous study for from GoCare 2017. ABS also will be dissolved out into liquid form. This is also from the previous study, the Wiki 2019. Then, ABS material are very durable, slightly flexible, and lightweight, which make it perfect and can be easily extruded for 3D printing, and suggested printing at 280 degrees Celsius to 240 degrees Celsius with an 80 degrees Celsius or higher heated bath. This is also by finding from Zeki Hay 2019. ABS particularly useful for objects requiring flexibility and strong self-bonding among layers based on Horn 2017. Refers to the table 6.1. This is the properties and specification of ABS HBN resin. ABS resin from Chess EduPack software. That is hexagonal boron nitride, also called white graphene, which has a crystal structure similar to the graphite hexagonal. This crystal structure offers lubricating properties and chemical stability with excellent. This is from the previous study theme 2019. HBN was selected in the manufacture of this composite. There is no cleaning method in HBN because it is in the powder. Particle with hexagonal crystallographic structure were 99.8% priority. Table 6.2 show properties of hexagonal boron nitride from MK Impact 2020. For acetone, acetone is also identified as HTCOCH3 and it is a flammable liquid category. Acetone is a water miscible and it's also a major solvent, usually it lacks for cleaning purpose. But then in this project we use acetone as the mixture of ABS HBN to make the strong bonding between that composite. It is volatile and flammable due to the Jessica 2019. Acetone can also be used to limited extent for the formulation of nail polish removers in household items like cosmetic and personal care products. In table 6.2 shows physical and chemical properties of acetone from Merck's 2018. Now we proceed to the process. First is ABS HBN mixing. Start with the combination of ABS with acetone mixed mechanically about 24 hours and mix with HBN with 20 grams and goes to the ultrasonic aggregator about 45 minutes and then pour into a glass plate and store in oven about 60 degrees Celsius for 7 days and become solution formulation. Then from process is number 2, producing the filament of pure ABS and composite ABS-HBN through rheology testing. First, turn on the machine and set the parameter and waiting for the temperature. The parameter that we set is for the barrel diameter is about 50 mm, while for capillary length is about 20 mm, and for the temperature we set at 230 degrees Celsius and preheating time at 300 seconds. And then after the parameter and temperature with the setting that we want, we proceed insert the material and run the process and see the graph and the data variation at computer, because when the successfully product produced filament are produced, the graph will show the data as the stated in the graph in the pictures with the graph line green. The line green shows that the filament produced from the machines, and then lastly collected the filament product. And then we proceed to the producing the filament of pure ABS composite and ABS HBN through the process, which is turn on the machine is the number 1 of the slide and set the parameter and its temperature. The temperature that we set consists of 5 which is start with 67 degrees Celsius and 200 degrees Celsius, following by 230 degrees Celsius, 230 degrees Celsius, and 220 degrees Celsius, which this parameter are need to be constant. And then insert the material, then run the process and collect the filament produced. Therefore, the crushing process, the dry composite meats must be cut into small part around 5 times 5 mm before crushing process. The solution mixture then undergoes a crushing process to get the correct amount. This method will use a chisel crusher machine to get the desired scales. Then for the rheological testing and analysis, the capillary rheometer testing provides a plot of viscosity versus shear rate. Capillary rheometer in Tranchis Smart Series SR20 patent are used to measure the viscosity of polymer melts based on the rate of deformation and temperature. The pressure also be study from this rheology testing. And then a rheometer is used for measuring the rheological characteristic of the material ABS, HBN, composite, and also for the pure ABS. The study of rheology on the deformation and flow of matter, which describe how energy, deformation, and time interact. Then we proceed to the extrusion. The process of extrusion is an easy process and be carried out where the molten polymer is pushed into a shape die by pressure. The pressure is caused by the actions of the rotations of the screw against the barrel wall. The machine be operated precisely by using seat head zones, which are intake, melting, venting, mixing, vacuum, and metering zone. Proceed to the microstructure observation, which for the microstructure observation we use two types of machine, which one is optical microscope at 100 of magnification, and second one is by using the scanning electron microscope SEM. For the optical microscope, which is also known as a light, use a light and lens combination to magnify an image in the view of tiny objects such as cell. Optical microscope are used. The latest magnification of this type of microscope is not usable, and this minimal structure exists in the viewing of a cell. For scanning electron microscope, scan a directed electron beam over an picture surface. The electron in the beam communicate with the sample and create different signals to obtain information about topography and composition of the surface. The aim of the observation are to see the properties of material for ABS and HBM, where the mix of HBM to the ABS will be affect the structure of ABS, HBM microstructure. Then from the rheology testing and extrusion process also give an effect to the microstructure of the material. Then we proceed to the result and discussion consists of two types, rheology testing and also the extrusion. We go first to the rheology testing of pure ABS and composite ABS HBN to the shear rate viscosity. The results show the viscosity decreasing with increasing of shear rate, which generally decreases with increasing temperature. The increase in intermolecular interactions connected with the amount of free volume available to the molecular chain. The temperature was rising. The material composite ABS HBN had high viscosity at 234.5 pascals second compared to the pure ABS due to the high flow resistance and the molecular, which give a lot of internal friction among composite material. This result also a previous study finding are not similar, where the viscosity, which is the higher value, are stated to the pure ABS by the Wiki 2019. This is I think because of the composite ABS HBM that I use for my project, which is the age of composite ABS HBN is already stored about 1 year, so I think the properties material are already changed, maybe due to the temperature. Then cause the different result that I got from previous and for my result. And then proceed to the second one is rheology testing of pure ABS and composite ABS HBN to the shear rate pressure. The result increasing in the pressure for both pure ABS and composite with the increasing of shear rate give an increase in stress pressure solid state. The pressure increase in the molecular force of the attraction between molecules which lead to decrease in viscosity. The ability of adhesive to resist wearing due to the contact with another surface of pure ABS and composite ABS HBN makes the missing composite ABS HBN are higher in pressure than pure ABS. Similar result has been obtained by Wiki 2019. The experiment about characterization of acrylonitrile botanic strain has a number on nitride composite for 3D printing. Then for the third extrusion of pure ABS and composite ABS HBN, the result gives that the parameter of skew speed RPM must be faster, need to be adjusted to high speed, so it can make sure the product that will be produced are thin and can be processed in the 3D printing process. The diameter for pure ABS are stable in the process, which around 1.75 to 1.80 mm, less than composite ABS HPN, which is around 1.83 to 1.86 mm, as shown in the figure 7.5 and also figure 7.6. The pressure only increases in the directions of the flow and the density of the material is constant. The screw barrel also play an important role, which screw barrel system is at the heart of the extrusion process and determine its performance, and the flow of the material ABS and HBN result from the action of the screw flakes on the polymer in contact with the inner wall of the barrel. Similar results have been obtained by referring to the Purity Brunner's work 2014 from the book Polymer Extrusion. Then for the number 4, microstructure observation by using optical microscope to the filament from rheologic testing of pure ABS and composite. The results show 20 of magnification where the fracture effect to the structure of sample at the dark side unit of the highest length to see the clearly about the microstructure or the effect, and it is the part that more inside as compared to the light side. The structure are not too good at the head also combines the parameter due to the rheology tests are not stable at the beginning, because at the beginning of process we need to waiting for the perfect parameter that we want. Then the surface parameter, the surface of microstructure at tail sample are better than head part, which is not too much of that side. We show the more of fracture structure. Then the microstructure of composite show a good interfacial bonding between ABS and HBN. Then for number 5, microstructure observation by using optical microscope to the filament from extrusion process of pure ABS and composite. The results show 20 of magnification where the microstructure are too rough at heat, pure ABS and easy to break, or ductile, which ductile refer failure of highly ductile material is in case materials pull apart instead of breaking due to the unstable parameter at the beginning of extrusion process. Generally, filament extrusion resulted in poor quality material, porous microstructure, severely weak and mechanically properties, and inconsistent printer ability. But the microstructure observation to the composite sample, the surface is too smooth for both head and tail. This is caused by the combination of ABS and HBN, which consists of the strong bonding by each other. This finding is consequence will take research by Worsley 2018, where a similar return to the microstructure done. So number 3 is microstructure observation by using scanning electron microscope SEMs to the filament for rheology testing of pure ABS composite. The results show 10,000 of magnification where the microstructure results of the observation consists of the third surface that too rough for tail part pure ABS, while the head of the microstructure consists of the bubble effects and not too smooth. In composite ABS HBN sample, there is a big perforated effect on the microstructure of head part caused by the unstable parameter at the beginning that make the structure on head part not too close by each other and the sample easy to break. The microstructure at tail part of composite more smooth and less perforated effect. The composite show a good bond between ABS HBN with the low effect to the inner structure. Similar finding is consistent with the previous study by Dewicki 2019, where the same on the shear surface microstructure effect to the sample from the rheology testing. For number 7, microstructure observation by using scanning electron microscope (SEM) to the filament from the extrusion process of pure ABS and composite, also at 10,000 of magnification, where the microstructural result of the observation consists of third surface at pure ABS filament, means the broad composite in the filament through extrusion process. There are differences in color and contrast show that the particles are well dispersed. The extrusion sample for head composite revealed too rough of microstructure as compared to the tail due to the high due to the beginning of process need to reach the stable diameter, which for pure ABS are at 1.75 mm, while for composite ABS HBN around 1.80 mm. The temperature during the extrusion process will make the strength of the material property change, and the structure of particle also change to the pure ABS composite. The addition of boron nitride particle resulting in a higher degree of freedom of polymer change motions at a lower temperature during heating. According to the Vosley 2018, filament extrusion resulted in pure quality material, porous microstructure, severely weakened and mechanically properties, and inconsistent breathability. Then we next to the project potential. First, the study finding could be applied in the 3D printing industry. Then, with the unique combination provided by composite ABS HBM material that make it desirable for heat dissipation and packaging applications in electronics. This is due to the high thermal conductivity of the composite. This is also supported by the previous study from Shahriar 2015. Then for the second one is high temperature project. ABS has a higher tolerance for heat compared to other plastic, making 3D printed ABS object useful in environments where the part encounter relatively high temperature, such as inside cars or around cooking equipment. Then for the third one is the parts of inside car and the cooking equipment are widely used in community, and the industry are highly rapid on the produce the equipment. This is also can low cost and give the best quality to the product and sustain the ecosystem that less of consumption of the resource. Less the consumption of resource that make the ecosystem are stable. And then we for the conclusions. Hexagonal boron nitride HBN and ABS composite filament has been successfully developed. The study of the effect of material properties of ABS, HBN, composite, and pure ABS on the relative properties of ABS, HBN, and pure ABS reveals that the shear viscosity decreased while the shear rate increased from 200 to 1000 of shear rate. Because for my study, I start a shear rate about 200 to and add and the NY for 1000 of shear rate. Because of the high flow resistant composite ABS HBN and had higher viscosity as compared to the pure ABS. The pressure for both pure ABS and composite ABS HBN increase when the shear rate increase. Where this happens because of increase in the stress pressure solid state. Then study the effect of extrusion gives that the parameter of these extruded machines, such as the melt temperature and pre-drying time, cause an effect to the properties of the material on pure ABS HBN and also for the composite ABS HBN. The diameter for pure ABS are stable in the process, while just around 1.75 to 180 mm, while for stable value of composite is around 1.83 to 1.86 mm. Observation to the all sample from relative testing by using optical microscope and also scanning electron microscope is same. And extrusion at the part of head and tail give an effect such as shear surface. Okay, that's all from me. Thank you for your attention.